Hi students, now I'm going to teach a topic on resolution, dead time, dead zone, hysteresis error and drift. So first of all, what is resolution? The smallest change in input value that can be measured is called resolution. So I can give a formula of resolution as full scale deflection value by total number of divisions. So it is defined only for linear scales. The next, as the number of divisions increases, resolution increases for same FSD value. So that is the reason it is defined only for linear scales. It is defined only for linear scales. How it is defined? So first, I will take two linear scales. The same 0 to 10 volts. Okay, now so here I will take 1 2 3 4. So 2 volts, 4 volts, 6 volts, 8 volts, 10 volts. So what is resolution is equal to FSD value by the total number of divisions is equal to 2 volt per div. So again, I can give here 0 to 10 volts. So here I will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1 volt, 2 volt, 3 volt, 4 volt, 5 volt, 6 volt, 7 volt, 8 volt, 9 volt, 10 volts. So what is R is equal to total FSG value by total number of divisions is equal to 1 volt per div. It is a 1 volt per div. Okay, now so this is preferred. Okay, now this is preferred. If I give two scales, we prefer only this. Listen here for a while. As the number of divisions increases, resolution increases, means picture clarity is getting increased. So I would like to conclude the same point. As the number of divisions increases, resolution increases for same FSD value. Think as an engineer, not as a mathematician, because if you substitute this in the formula, see, as the number of divisions increases means what? Your resolution should decrease. But what I am speaking here, as the number of divisions increases, resolution increases for same FSG value. So B as an engineer, picture clarity is getting increased. Then next, what is threshold? The smallest input that can be measured is called a threshold. What is threshold? The smallest input that can be measured is called as a threshold. Then next, what is dead time? Dead time means even after giving input value, meter takes a minimum time to indicate output value. This minimum time is called a dead time. So what is this dead time means? The moment I give 4 amperes, it can't show 4 amperes. It takes some time, twisting and all. So that particular time I am treating it as a dead time. Even after giving input value, meter takes a minimum time to indicate output value. This minimum time is called as a dead time. So what is dead zone? For a large change in input for which there is no change in output in some portion of the scale means, what is your dead zone means? The moment initially I am giving 4 amperes on a 10 ampere scale, 0 to 10 amperes, I am giving 4 amperes here. The moment I give 4 amperes, it is showing some 4.3 amperes. The moment I change my input to 4.05 amps, still also it is showing the same. So what? A particular thing, I am naming it as a dead zone. That is what? For a large change in input, for which there is no change in output in some portion of the scale, this portion is called dead zone. So let's have a graph for it. So if I take here as an input, if I take this as an input and this as an output, then this particular time is called dead time. So, and how I treat as dead zone. The moment I take here, if I take here, so what is my dead zone? If I take this is as an input and this as my output, so this particular thing is called dead zone. And this particular value is called as a threshold. So once I combine the both, so I will take this as an input or output. I will take this as a time. So this particular is called as a dead zone. This is dead time. So this is your measured value. This is your measured value, AM. This is your measure end. True value. So then next, what is a hysteresis error? For ascending values, meter indicates less than actual value. And for descending values, meter indicates more than actual value. Meter indicates two different readings for same input value called a hysteresis error. So what is the meaning of it is I'm giving here 4 amperes, here also 4 amperes. So but how I got here 4 amperes is on a 10 ampere scale. Initially it is at initially it is at 8 amperes. Initially pointer is at 8 amperes. Now I made it decrease it to 4 amperes. In this case, it will show 4.2 amperes. So here, initially it is at 4 amperes. Initially it is at what? 0 amperes. Now I am increasing it to 4 amperes. So what here? Initial, it is traveling to 8 to 4 amperes. And this is traveling to 0 to 4 amperes. See, it is traveling 8 to 4, it is traveling 0 to 4. Both the destination are same. This is my true value. This is my true value. In both the cases, 4 amperes only I am giving. But see, for descending values now, 8 to 4. In this case, it will show 4.2. And ascending values, it will show what? 3.8. It will show. That is the reason for ascending values means 0 to 4. Meter indicates less than actual value. 3.8 is less than 4 amperes. And meter indicates for descending values means 8 to 4 is descending values. Meter indicates more than actual value. Then meter indicates two different readings for same input value is called. See, for same 4 amperes, it should represent 4, but in this case it is showing 4.2, in this case it is showing 3.8. So meter is showing two different readings called hysteresis error. Next, what is a drift? It represents a slow variation in output signal of a transducer or an instrument, but this variation of output not due to change in input. Repeat finally in a simple language, what is the meaning of it is output is changing, but input is not changing. Input is stationary, is fixed, but output goes on changing. What might the factors? That is what it represents the slow variation. It represents the slow variation in output signal of a transducer or an instrument, but this variation of output is not due to change in input. Actually, if input changed, then only your output should change. But here, input is constant, it is not changing, but only output goes on changing. What are the factors? So due to surrounding temperature, environmental conditions, interference due to magnetic fields, noise signals, due to long period of operation of an instrument, mechanical stresses will be developed, change in stability of the components, heating effect. Heating effect. So all the factors. So the next drift is of three types. Drift is of three types: zero drift, sensitivity drift, zonal drift. It is of three types. What is drifting meaning means movement. Drift means movement only. Drift, zero drift, sensitivity drift, zonal drift. So let's go deep into it. What is exactly each? What is zero drift? See, what is zero drift means? This is input, and this I can take it as the output. So what is this zero drift means? Actually, my line should be of very linear. So what this is of Ideal. This is ideal. Ideal line should be like this. The next zero drift. Zero drift means it goes on parallel to this. Exactly lies parallel to this. So this is what your zero drift. This is called as your zero drift. Zero drift. It's called as a zero drift. The next, see, observe here, whenever input is zero, output should be zero, but there exists some output that is called as zero drift. Initially input is zero, but output exists, that is called as a, so the next I can give in a simple terminology. What is zero drift is when drift is present, when drift is present, input is zero, but output is not zero. So now the next step, let's come for sensitivity or span drift. So actually this is your nominal characteristics now. Actually this is of input, this is of output. This is nominal characteristics. Nominal characteristics. So this is characteristics due to is characteristics due to drift. So then next let's go for zonal drift. What is zonal drift? So span drift plus zero drift. So what this consists of both now. So this is my output I will take here. So I will take this as a, so observe here, It is increasing and also decreasing. So this is what your input. So this is what your output. It has a combination of span drift and also zero drift. Then next, let's come for types of static errors in the coming video. Thanking you.